Hi, everybody. My name is Mutwana Wabantu. Never skip a day. Practice day. Gameplay. Let's wait. Easy say. Easy play. Let's get started, man. So never skip practice day. It's easy say. Easy play. Now look, man. So we have a question right here to say 20 kilogram. Let's move face the calculator because we don't need calculator right here. Okay, let's move to the left a little bit. Okay, so we're gonna move calculator to the left and let's get started. This is the easy play. Now. So let's say here, So let's say here, let's say a 20 kilogram mass block racing on a rough horizontal surface. Oh, so look, this is surface here like a table, but it's a rough. Meaning, if this stuff, let's say, move, let's say, to the right, we assume, meaning the friction force, since it's rough, the friction force is going to be opposite. Let's assume it accelerate to this side, means the friction force is going to be acting what? Opposite. But if it's moving the opposite direction, let's say it move to this direction, means the friction force is going to be opposing. Because you know why? Because it's rough horizontal surface. So now let's see face. We need to determine which direction does it move, okay? So we can do easy play. Either move to the left or move to the right, okay? Now let's read because we can only know that by reading. So our block is 20 kilogram and it's connected to the black P and Q. Oh, so look, is connected. So here we have like a pulley. So it's kind of all the way connected to the black P and Q. But all these together, you call them what? M. That's how they call it, okay? Easy play. Now they say we have what? A light inextensible string. Oh, so this string here is inextensible, means very thin. It's very thin, like a weightless, means it does not have a weight, okay? So now they say, look, this is like a string here, look. And then they connect to two blacks, but these two P and Q, they give us what? M, and this is strange all the way, and they come in. It seems like they pulled there, but let's read. Okay? So let's say together have a combining mass of M. P and Q, they have a combining mass of M. Now, a force of 35 is now applied to 20 kilograms. So me, roughly, by thinking quickly, why do we apply a force on this? Because maybe it was moving this way, but let's read. That's why we apply the force to pull it like, hey, come here in an easy way. Come back. Okay? So that's why we apply the force, but let's read. So by the way, quickly by looking, there's a possibility this object is moving this way. This way means this direction, but let's read. Don't do assumption. So your intention phase, you want to know what the direction where an object it accelerates. Okay? Now let's go and read the question. Now they say is applied today. 20 kilogram is applied this force here today. See? We pull by 35 on this 20 kilogram on the angle 40. Oh, on the angle 40 means they did not pull it like this way horizontal. No, they just put in a certain inclination. Maybe because it was falling so hard. So they say, you know what, we need to pull it like 36 Newton. Now, what do they want? They say here 20 kilogram blocks experience a friction force magnitude of 5. Oh, so the friction force is 5. But we still want to know like where object moving. We're not yet known, but roughly we know it's going to be moving this. Okay, let's read. It was moving this way. Assumptions we not know yet. That's what was pulling it back. Like, hey, come back, please. Don't go there. You understand? Like easy way, in an easy way, like you play, huh? So now they say here, look, they say an object was moving to the right in a constant speed. Oh, so now we know this object was moving to the right. That's what was pulling it. Also, it was accelerated this way. Means it was accelerated. A means acceleration. It was going this direction. Now, so for that case, now we know a friction force always opposing the motion or the direction the object was moving. Means if this object moving this way, the friction force is going to be opposing like this. Because opposing this object moving that way, so the friction force is going to be opposing. Now let's go to the first part. Now they say with a constant speed means this object is moving the constant speed. Okay. Now they say define the normal force. Listen here. Normal force is easy. Listen, family. If you have, let's say, horizontal surface like this, okay, and now you have your mass or the object of mass m. Look, any object, it always have a force of gravity. Force of gravity, the force which acting toward the center of the earth. Okay, so now from the Newton's third law of motion, since this object A or object M act toward the center of the earth, but it exerts the force on the table. then the table is going to say, hey, listen, you push me, I'll push you back. Means the table also is going to exert similar force but opposite direction. So these forces come from the table toward an object which lie on the surface. So normal forces start from the, so go normal first. Means start from the surface where, because M acting, it has a weight which acts on the table, and the table say, hey, listen, you put pressure on me, I put pressure on you. So he acts also force of normal. So force of normal start from here on the table toward the object, and the force of gravity start from the center of an object M toward the center of the S. Direct one. That's why when you have an object always falling, because see, there's a force of gravity which acts toward the center of the Earth. Okay? That's why when you have something like this, when you see falling, because you know why? Because it has a force of gravity. Now, so what is normal force? Normal force is this Fn. So Fn is the perpendicular force. Look, it make angle 90. Is the force of perpendicular. Is a perpendicular force exerted by the surface, because it comes from the surface toward the object. See, it comes from the surface toward the object. Like here, the normal force is going to sound like this. Look, because the object 20 kilogram, it exerted force toward the table or to the center of the Earth. And this guy say, hey, listen, don't give me force. You know, I'm gonna react to. I don't like the way how you put more force to me. You know, so I'm gonna put also normal force in an easy way. Oh, my handwriting, sorry, never mind. This must be vertical. From the surface to an object, and this is force of normal. See? So normal force is the perpendicular force. So let's put the right definitions. In the perpendicular force, normal force is the perpendicular force. Exerted by the surface. By surface only on an object, means from here surface on an object in contact with the surface. It's an easy play. We're done already. Now let's go to the next question now. Next question is this. So next question. The next question here, let's read first, okay? Reading is very, very important. So they say next question. They say here, okay, label the free body diagram of 20 kilogram. Oh, what is a free body diagram? So before you draw free body diagram on carriage phase, know the force diagram. Means, okay, they said only 20 kilogram. So look at your 20 kilogram face. These are 20 kilogram. Let's draw all the force which acting toward the 20 kilogram. So like I say, face, you need to know, okay, what is the direction of an object? We say these objects, okay, this object is going to be moving this direction, right? This direction. Meaning, if it's moving that direction and you have a force here, so we're going to say, okay, so our force diagram is like this. Look, we have a normal force, we have a force of gravity, and then here's a tension here, remember. Because tension is the force which makes this object moving to the right. And because, look, you're pulling it here, right, with 35 Newton. So anything which is opposing here is what is tension. And we have a tension here, means this object, remember, move this direction. So meaning we have a friction force which is opposing here. So what I've drawn for you here, this is a force diagram. I can draw like separate, for example, force diagram for the 20 kilogram is going to be the phase forces, tension, because on a rope we have a tension force, because on a rope or string. Now we have this force here, which is 35 Newton, force applied that you apply, and they'll have a force of gravity, and they'll have a normal force. So this is a force diagram here. This is a force diagram which I've drawn here. Force diagram. See? So now going to the free body diagram. Free body diagram means you just have to, okay, what you have to do, don't draw as a box, just draw as a dot. Let me do this. Okay, do like this. So this is a free body diagram. See, you don't draw a lot of things, or you do draw the lines of those forces. And you must make sure you define. You say, what is Fn? You say here Fn, whereby Fn is a normal force. Because otherwise you're not going to know. T is the tension. of inextensible strange, of inextensible strange. Oh man, it's easy. Okay, now we go for this 35 Newton is applied force. Force applied. Okay, it's applied force. Okay, applied force. Okay, now we go FG, force of gravity. Or gravitational force. Force of gravity or gravitational force. And then I think we explained everything. Tension, whatever. Okay, cool. So we have all the forces. So this is a free body diagram. Now let's go to the next one. Next question. Okay. Now next question here. They say calculate the combined mass of the two blocks. Which blocks? M and P. Oh, okay. So look. This is very, very crucial. Okay. Very, very important. So since this combined mass, so what you do, okay, when you solve this question, you do not mix two things. There's a horizontal motion and vertical motion. So now, where is P and Q? Is it horizontal motion or vertical motion? Look, this is a horizontal motion, like this is a horizontal motion. And then when it comes to this pulley, it turns direction, it goes to the vertical motion. So the vertical motion is here, and then we know, okay, so now here in two blocks means P and Q together, they were glued together. See, they were glued together, they were together. If you can read the question clear, they say they were glued together. Excuse me, sorry. So we say, since they were glued, means they have a force of gravity here. We can say, okay, force of gravity at the center. But what is the opposing? The opposing one here is going to be normal force. No, it's not normal force, my tension. We don't have normal force because normal force you have only when something acts on. Okay, normal surface only. Normal force is come from the surface, means surface to an object, and it must be force of gravity. So here we don't have a surface. This stuff is on air. So for that case, the only force which is opposing is tension here because tension is on a rope. This stuff is moving down by force of gravity, and something which is opposing is only tension, which is on a rope here. See? So now from the Newton's second law of motion, we say, since I want to deal with the vertical motion for this case, I'm looking for M, I'm going to say force net. So you must say this first. Newton's second law of motion from Newton. Second law of motion. How say? F net force equal to mass times acceleration. What is net force? Net force means take the bigger force minus smaller force. How you know something bigger? You know something bigger by looking the direction of the object. If me and you pull each other and I'm pulling you to me, means my force is bigger than you. Okay? So what I'm going to do, where this object is moving, this object moving down, you see? Because it accelerates this way. So meaning Fg is bigger compared to the tension because the only one force opposing here is tension. We don't have a friction force here. Yes, we don't have because this stuff is not on the surface, no. But on top here, we have a friction force. See? So we're going to say, no, we don't have a normal here, like I said, because we don't have a surface here. No surface. So we're going to say here, force net meaning take bigger force. Which bigger force here? Force of gravity minus which force opposing? Tension equal to mass. Mass times acceleration. This is Newton's second law of motion. But look, they mention something. They say this stuff move with a constant speed. Whenever an object either move with a constant speed, okay, or if it's a stationary, acceleration equal to 0. No acceleration. Let's say it again. This you need to memorize this, okay? But I'm going to explain to you how this comes about. When an object is at stationary, what is a stationary? Means it's standing. Like me right here, I'm not moving. Means I do not accelerate. I don't have acceleration. Or when you move with a constant speed, also acceleration equal to 0. So this is very, very crucial concept here. Constant speed. Oh, so for that case now, our A equal to 0. So M times 0 means mass times acceleration, mass, it doesn't matter how much mass you have, but since acceleration equal to 0, and then whatever times 0 equal to 0. So this is going to be 0. All of this is going to be equal to 0. So say F, G, but what is Fg? Mass times gravity. Mass, and we know this mass is a combination of what? Of P and Q. Mg minus T equal to 0. And what happened? We want to get mass. So T is going to go over, so it's going to be Mg. So I can simply say, oh, Mg equal to T. divided by G, this is this concept. So our M, which is a combination of P and Q, equal to tension over gravity. Oh, so I can write here, so I say, okay, so I know something here. What is the something? Mass we're looking for equal to tension times gravity. So we don't have a tension. Let's go this first equation. Tension we don't have. But a gravity we know is 9.8 is given. Gravitational force is constant, means it does not change 9.8. So now we say, let's find the tension. So I'm gonna play the same game that I did here, but now we go for the what? For the horizontal motion, because now we're kind of stuck. We cannot move because we don't know the tension, but a gravity we know. So now let's use this Newton's second law, but for horizontal motion. So for horizontal motion, so now I don't need this variable anymore. Look, where this object is moving, we identify with already identified. We say this object moving to the right. So what that causes, so what you can do, you can simply hide this. Just assume like, oh, you know what? I don't need this. You don't need all of this because now you deal with the horizontal. Means you only deal with this direction here. This direction. Let me say it again. You don't deal with this direction. This. Let me put yellow. That direction is a horizontal direction. So Newton's second law of motion, but for horizontal direction means we look, where is it moving? Means move to the right. So say F net equal to ma. So what is F net? Look, where is it moving to? It's moving to the right. Which cause moving to the right? The only force move to the right, this one, T. So we're going to say T minus all the forces which you're opposing. What is that you're opposing? Something which is opposite friction force, which is here, because if it's moving that way, means friction force is going to be opposite, which is the friction force. So we minus what friction force? And then we minus another force. There is this force. But this force, they're given a tricky way. Let me tell you what that means. So now we're going to come here, right? We're going to minus that force, but let me tell you how we're going to apply that force. So we leave it for now, just a minute. Let me show you something. If you have a triangle like this, let's say this is theta. Okay? And here they say anything. Let's say 4 Newton. So somebody say find the horizontal. Horizontal we know represented by x. So you have to remember one thing. Horizontal is cos. Horizontal is cos. Horizontal is cos. Simple like that. So we're going to say, okay, so horizontal is cos. So I'm going to say cos. What is my angle? Cos of theta. And then you must multiply by this hypotenuse, which is 4. That's how you get the value of x. Horizontal is cos. So if our angle, let's say 60 degree, means here I'm going to say what? 4 times cos 60 degree. What about vertical? Vertical is sine. Vertical is sine. Vertical is sine. Oh, so vertical is sine. So if I want to get this out of here, I'm going to say what? Sine. What is my angle? 60. We assume is equal to 60. And then multiply by the hypotenuse, which is equal to 4. So this is going to give us what? The vertical y. Vertical y. But we say horizontal is cos. So we could say again cos of 60 multiplied by the hypotenuse. For Newton. So we're going to play the same game here because we want horizontal force, family. And this is not horizontal. This is in inclination. So I can simply connect this triangle and say which force I need. I just need the horizontal force here, which is this one here. So horizontal is cos. So here I'm going to say because I need horizontal forces. Cos which angle? 40. And then multiply by this force here, which is 35. And the vertical, which I don't need, but I can just show you because I need horizontal. Okay, for vertical it's going to be sine. Excuse me, sorry. Vertical equal to sine of 40 times 35. This is going to give us what? Y. But for now, I just need what? Horizontal. So this is what I need. So now we're going to say tension minus all the forces opposing. Which force opposing? The first one is friction force. And another one also, we have to minus it, this force here. So even though the force was here, but I had to resolve it, and they give me 35 cos of 40. So we're going to minus what? 35 cos of 40 equal to ma. Mass we have equal to, 20, but acceleration equal to 0 because they say here this stuff is going to move with a constant velocity. Means it's going to be m times 0. It's going to be 0. Because mass equal to 20 times acceleration equal to 0, it's going to be 0. But you have to pay attention only if they say acceleration is constant. Only if they say velocity is constant. So when velocity is constant, let's see here, at the constant speed or velocity, acceleration equals to 0. Like we say. Okay? Now, what do we want? We want to get tension. Friction force we do have. They could have given us a friction force if I'm not mistaken. Let's go. Did I mention friction force? Do you have a friction force or not? Friction force do you have? Do you have a friction force? Oh, let's read here. Oh, yes, they gave us here. No, they didn't give us. This is force applied, which is 35. Now, friction force here, 5 Newton. Friction force of 5 Newton. Okay, so we can plug everything here. So we want to get tension, minus 5, minus 35, cos of 40, equal to 0. So let's get tension. So we say tension equal, go over. So this stuff is going to go over, man. Go over the side and you go over. So this negative is going to become positive. And this negative is going to become positive when you go over. So this is going to give us tension equal to plug in the calculator, that one. Man, should I really show you how to plug in the calculator? Cos of 40. You know this, but let's show you way easy play. So we're going to say here, come here, okay. Say 5 is 5, and then we plus 3 cos of 40. Oh, so it's 5. Okay, so this is going to give us 5.76666 something. Okay, we got it. But remember, we have to take this tension and come and plug here in the tension. See? So we're going to take a 5 function. 35. Did I get 35? No. Okay, take this one over. See? Take over.